All right, let's jump right into this explainer. Picture this. You wake up, grab your morning coffee, log into Slack, and realize your entire cloud engineering team has been completely replaced by an AI. I mean, imagine it. No more human engineers, no more late-night deployments, no more bleary-eyed debugging of production clusters, because an AI is just doing the whole shebang. It sounds totally crazy at first, right? But the more you actually look at what these tools can pull off today, the more you realize this really isn't just science fiction anymore.
So, the big question we really need to ask ourselves today is, can AI actually replace cloud engineers? Since AI is already out there writing complex infrastructure code, constantly analyzing massive streams of telemetry data, and detecting anomalies across distributed systems without a single complaint, it's a super urgent question. It's literally top of mind for everyone in the space right now, so let's break down exactly what we're dealing with. Just think about what these AI models can already pull off. Imagine a director just casually telling an AI to deploy our new application environment. Boom! The execution is practically instantaneous. In minutes, it creates the underlying infrastructure, configures all the complex networking, sets up the monitoring dashboards, and deploys the app seamlessly. And honestly, the wildest part? It does all of this requiring absolutely zero coffee breaks, no alignment meetings, and zero pushback.
And that relentless efficiency gets even crazier when you task an AI engineer with cutting costs. Say leadership tells the AI, hey, our cloud bill is way out of hand. Fix it. Immediately, it analyzes thousands of resources across every single region. It sniffs out unused instances, spots inefficient workloads, and instantly recommends cheaper configurations. It can slash a massive monthly cloud bill in seconds. Looking at that kind of rapid optimization, it's pretty easy to see why human engineers might kind of feel like they're in trouble. But then, one night, everything breaks. Out of nowhere, the entire platform just goes down. Customers are locked out, support tickets are piling up by the second, the primary database is acting totally erratic, and monitoring alerts are just firing off completely conflicting signals. The automated dream shatters, and the reality check hits really, really hard.
So, in a total panic, leadership turns to our perfectly efficient, automated system and asks for a fix. And the AI proudly declares it has found exactly 47 possible causes for the outage. 47. Which is almost funny, because it perfectly illustrates its fatal flaw. When you ask it which one of those 47 causes is actually bringing the system down right now, it doesn't know. It entirely fails to pinpoint the actual root cause. Suddenly, handing the keys completely over to an AI doesn't seem like the smartest play.
Which brings us to section 1, the human advantage, and having context beyond the logs. See, fixing a major outage isn't just about reading a stream of data. It requires deep systemic comprehension. Human engineers excel because they instinctively ask the complex, context-heavy questions. Like, why was this architecture designed this way 3 years ago? What happens to our legacy stuff if we change this specific database? In a crisis, do we prioritize immediate availability or cost? And crucially, human engineers know that sometimes the real issue isn't a highly technical glitch hidden in a log file. It's just a bad deployment someone made 5 minutes ago that they definitely weren't supposed to. Humans actually grasp that nuance.
So what we're really looking at is a definitive split in how engineering operates from here on out. On the one hand, AI handles the repetitive, data-heavy execution. It's incredibly good at analyzing telemetry, automating deployments, generating boilerplate code, monitoring clusters, and optimizing costs. But on the flip side, humans provide what a machine simply can't: architectural judgment, an understanding of shifting business requirements, and ultimately taking real responsibility for the system. You manage the unexpected failures. You balance the complex trade-offs. To give you some real clarity on your future output, this is exactly how your day-to-day is going to change. It frees you from the tedious manual tasks so you can actually deploy your brainpower where it matters. Instead of burning hours manually tweaking infrastructure, you'll be designing better, more resilient systems. Instead of staring blindly at thousands of logs, you'll let the AI find the important ones so you can interpret the business impact. Instead of writing repetitive code, you'll guide the AI as it generates it. It's a massive, super practical evolution of your workflow. Which leads to what is probably the absolute reality check of the entire industry right now. Maybe the biggest threat isn't AI replacing cloud engineers. Maybe it's cloud engineers who know how to use AI replacing cloud engineers who don't. Just think about that for a second. That is the new reality. So to be absolutely clear about where this career is headed, your roles are evolving. They are not disappearing. You aren't going to be competing against AI. You're going to be collaborating with it. You'll be combining the rapid, automated execution of AI with your own human decision-making in strategic context.
The engineers who learn to master that collaboration, they are going to become unbelievably valuable to the industry.
So, I'm going to leave you with this final thought to kind of spark your curiosity. Will AI eventually replace cloud engineers, or is it going to make them even more powerful? How are you going to evolve your own skills alongside these new tools so that you're the one harnessing the power of AI rather than being intimidated by it?